Hello, good morning everyone. This is Form 1 Mathematics, the first video lesson. In this first video lesson, today we are going to see Pythagoras Theorem. Before stating what the theorem says, we define terminologies that we are going to use in solving different problems related with this Pythagoras theorem. The first one is a right-angled triangle. We know that a triangle is three-sided figure which has three vertices and three angles. So again, triangles can be classified into different groups based on their side lengths and the degree measure of the interior angles. So from these different angles, we have a triangle. From different triangles, we have a triangle called right-angled triangle. So right-angled triangle can be defined as it is a triangle in which one of the three, as I said, we have three angles. From these three angles, if one measures 90 degrees, then the triangle is said to be right-angled triangle. So the first term that we are going to use in this Pythagoras theorem is right-angled triangle. And the second term is hypotenuse. Hypotenuse is the longest side which is opposite to the right angle. Right angle means the angle whose degree measure is 90 degrees in a given triangle. So the side which is opposite to this right angle, we call it hypotenuse. And again, this hypotenuse is the longest side. It is the longest side of the triangle. And the third term that we are going to see under this Pythagoras theorem is leg. It says the other two sides are called the legs of the triangle. I told you that a triangle has three sides. And then if right-angled triangle is given, from these three sides, one is called hypotenuse, which is the longest side opposite to the right angle, and the other two sides are legs of the triangle. They are termed as legs of the triangle. Now look at this triangle. We have given triangle here. That means a triangle or a plane figure with three sides, the second side, and this one is the third side. So as you can see here, we have given A, this one is B, and this one is C. That means these A, B, and C, they are sides of this given right-angled triangle. This triangle is right-angled triangle, and the right angle is at this corner. As you can see, this shows that the triangle is right-angled triangle. And this angle, we call it right angle, whose degree measure is 90 degrees. And the side which is opposite to this right angle is side C, which is the longest side, or the hypotenuse of the triangle. So we defined hypotenuse as it is the opposite side to the right angle, So the right angle is here, and the side which is opposite to the right angle is C, so C is the hypotenuse. And A and B are the other two sides which are called legs of the triangle. So those A and B are this side and this side. So you can name this as B and this one as A, or this as A and this one as B. No difference. The legs can be named, or you can use the names interchangeably. But C is the opposite side, which is opposite to the right angle. Okay, now let us see the theorem. We have defined the three terminologies that we are going to use in the Pythagoras theorem. Now let's state the theorem. The theorem states that in any right-angled triangle, now look, the first terminology defined there, right-angled triangle. In any right-angled triangle, the square of the hypotenuse, it says the square of the hypotenuse is C, which is opposite to the right angle here. So the square of the hypotenuse means c square. As you can see here in this box, we have given c square. It is equal to the sum. It says the sum means the addition of two addends, the sum of the squares of the other two sides. The other two sides are a and b. So the squares of a and b, the sum of the squares of a and b is equal to the hypotenuse square, which is c square. So here the hypotenuse is c, which is opposite to the right angle, and a and b are the two sides called the two legs of this right angled triangle. So the theorem states that in any right angled triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. That means c square, c is the hypotenuse, is equal to a square, a is one of the legs, plus b square, b is the second or the other leg of this given right angled triangle. Okay, now let us see this example. The example says, calculate the length of the side marked x. As you can see here, marked x in each of the following triangles. Now we have given three different triangles. Here we have given triangle A, here we have triangle B, and triangle C. So we are asked to find the length of the sides marked x. Here we have x. Again, here we have given another x, and in the third triangle we have the third x here. The third x here. So let's start from the first triangle. So as you can see, this x given here is the side which is opposite to the right angle, So this x, it stands for the hypotenuse. X is for the hypotenuse. So the solution, it says c square, which is the hypotenuse square. By definition, it's given. The hypotenuse c square is equal to a square plus b square, where a and b are the legs. A and b are the other two sides or the legs of the right angled triangle. But in this triangle, what is c? C is the hypotenuse, which is given by x. So instead of c, substitute x. So here we have x, it says c squared, that means x squared, which is equal to a, which is 8 centimeter given here, or you can use 6, you can use a or b. As I said previously, we can change a, or we can use a instead of b and b instead of a. So a squared, here we have 6, we used 6 instead of a, so 6 centimeter, the whole squared, plus b is 8 centimeter, so 8 centimeter, the whole squared. Here we used simple substitution in the formula. The hypotenuse square is equal to the sum of the squares of the two legs or the two sides. So x squared, here we have x squared, which is equal to square 6, use calculator and then you can square it. 6 squared is 36 and centimeter square is squared centimeter, plus 8 squared is 64, centimeter squared is square centimeter. Now add these two values, 36 and 64. So we have x squared, which is equal to 100 square centimeter. 100 square centimeter. So to find x, put this under radical or under square root. You can put again the value here under square root, so that using your calculator, the square root of 100 square centimeter is 10 centimeter. 10 centimeter. So the value of x, or the length of the hypotenuse for this triangle, is 10 centimeter. Example A. Now let's see example B. In this example, we are asked to find the value of x. The same, the value of x is asked here. X is one of the legs, because one of the legs is given by 13 millimeter, and the other 85 millimeter is the hypotenuse. We defined hypotenuse as the side which is opposite to the right angle, and it is the longest side. From all these three sides, the longest side we call it the hypotenuse. So again, we defined the Pythagoras formula as c square, which is the hypotenuse square, is equal to the sum of the squares of the legs or the two sides. So c square is equal to a square plus b square. What is c square? Our c, or the hypotenuse, here is given by 85 millimeter. So substitute here. Instead of c, we substitute 85 millimeter, the whole squared, which is equal to a. A is not known. It's given by x. So instead of a, we write x, the whole squared. Then plus b. Here we have given b, which is 13 millimeter. So substitute 13 millimeter here, so that we'll have 13 millimeter, the whole squared. Then using your calculator, you can square this value. 85 squared will give us 7,225. Then square the millimeter or the unit. So you will have millimeter square or squared millimeter, which is equal to x squared plus, again, use your calculator and square this value. You will have 169. Then square the unit, millimeter, will have millimeter square. Then 7,225 millimeter, the whole squared, is equal to x squared plus 169 millimeter squared or square millimeter. Now to find x, or to find the value of x, what we are going to do is we collect like terms. That means if we have values, numbers, that means numbers, we write those numbers to the same side of the equation and variables to the same side of the equation. So as you can see here, we have x squared. So leave x squared as it is, or write it here, and then switch this 169 millimeter square. That means collecting like terms together. So take this 169 millimeter, the whole square or square millimeter, to this side. So we'll have what? 7,225 squared millimeter minus, because here we have plus. Okay, when we shift this or we move this to the equality sign, I mean to the other side of the equality sign, signs will be changed. If the sign is plus, it will be changed into minus. If the sign is minus, it will be changed into plus. So here we have the plus sign, so that it will be changed into minus. So we have 7,225 millimeter squared minus 169 millimeter squared or squared millimeter. So subtract or find the difference between these two values. Then x squared will be 7,056 square millimeter. So to find the value of x, as we did in example A, do the same thing here. Put this under square root or under radical. Again, put this under square root or under radical. Using your calculator, you can determine the value of x. So the value of x is 84 millimeter. 84 millimeter. That means the side which is not given or not known and then given by x is 84 millimeter. Okay, now let us see example C. In this example C, again, as we have said, the side opposite to the right angle, which is given by 15 centimeter, is the hypotenuse. It's the hypotenuse, and one of the legs is 9 centimeter, and the other leg is not given, which is x, not known, which is x. So the question is finding the value of x. All right. So let us apply the same formula that we used in example A and example B, which is c squared is equal to a squared plus b squared, where c is the hypotenuse, a and b are the two legs. But what is c, or what is the hypotenuse? As you can see, c, or the hypotenuse, which is opposite to the right angle, is 15 centimeter. So instead of c, we write 15 centimeter, so the whole square is equal to a, one of the two, either x or 9, you can use one of the two, but here we used x instead of a, then x the whole squared plus b is 9 centimeter the whole squared. Now the question is finding value for x, or the length of the unknown side. Alright, now square this value, because it says 15 centimeter the whole squared. Square it. When we square this, we'll get 225 square centimeter. is equal to x squared plus square 9. 9 squared will give us 81 square centimeter. 81 square centimeter. Now again, as we did in example B, we'll do the same thing. That means we collect like terms. So leave x squared as it is. Here it is. And then take this 81 square centimeter to this side. The sign here is plus. So this plus sign will be changed into minus. So we'll have 225 square centimeter. The plus sign will be changed to minus 81 square centimeter. Here it says meter, write centimeter. Instead of square meter, the unit is square centimeter. Square centimeter. Okay. The unit is not meter, it's a square centimeter. Okay, then I have x squared here, x squared, which is equal to the difference between these two values. 225 minus 81 is 144. 144. So as we did for the first two examples, to find x, put this under radical. Again, put this under radical. So we have x squared. The square root of x squared is x, and the square root of 144 is 12 centimeter. 12 centimeter. So that we go back to the triangle, and this 15 centimeter is the hypotenuse, which is the longest side opposite to the right angle, and one of the sides is 9 centimeter. The unknown x, it is calculated as 12 centimeter. It's calculated as 12 centimeter. Now let's go back and then summarize the theorem. Okay, the theorem says in any right-angled triangle, if you have given right-angled triangle, so to identify whether a triangle is right-angled triangle, there should be an angle whose degree measure is right angle or 90 degree. So if there is an angle whose degree measure is 90 degree in a triangle, that triangle is right-angled triangle. So in any given right-angled triangle, the square of the hypotenuse, which is c squared, the hypotenuse is the side opposite to the right angle, is equal to the sum of the squares of the other two sides or the legs, So if you have given any right-angled triangle, and if you are asked to find one of the sides, you apply this formula. Then using your calculator, easily you can determine the length of the unknown sides, of a given triangle. Okay, this is all about Pythagoras theorem, and then what I have for today. But you have assignment, the second assignment. I gave you last time the first assignment, and I hope you did, and that you submitted the assignment to your parents. You will do the same thing here.